Hey, hello, this is the Ultimate Ladybug course video number 22. In video number 21, we looked at how we can use Galapagos together with the Ladybug Tools view analysis. But since I installed the Ladybug Tools 1.8, I thought it would be good to recap a bit of the changes. There are a few new tools available now, also for the view analysis, and let's jump into that. Before, two shoutouts. I have two new members, which is absolutely amazing, and I'm super thrilled. We have 12 days ago, joined 12 days ago, Siran Hongyot. I hope I pronounced it correctly. I've never been to Thailand, so I need to get the right sound into my ear. Absolutely amazed that you joined, that you see some value in my channel and that you want to support it. And then we have joined 8 days ago, Sofia Muñoz. There's not much on the channel, on her channel, but I can see for sure she's a designer or architect. And yeah, tell us about yourself. It would be great to get to know you. And also thank you very much for supporting my channel and be part of this very small community. Both of you, please reach out if you have any question, if you have any urgent requests, let me know. All right, let's jump into the view analysis or the new tools available in Ladybug 1.8. All right, so in the last video 21, as I said, we kind of reconstructed my initial buildings, or the buildings I had with Grasshopper. So we made a Grasshopper version out of it, and we created these facets. So it's not just round buildings, but they actually have segments, which is probably the way to go. Yeah, we used the view analysis, the view percentage. Now I explained already what that does, and there are different types. This is basically the view to the outside. You have an object, for example, a hotel. I explained it before. Yeah, for example, I have a hotel and you want to understand where do I need to place the rooms for the guests where they have the best view. And that you can use, for example, this study. Not just for that use, there are different ways to look at the view percentage. How much view to the sky, how much view to the spherical kind of calculation, sky exposure, and so on. In Ladybug Tools 1.8, there are a few new tools here which look very interesting. So we have, for example, we have the view factor, Ladybug view factors, and the view rows. I think is also new, if I'm completely wrong, or something which came back because I think that was gone previously. Let's see. We'll find out. Let's look at the view factors. This is the view percentage. And now let's look at the view factors. It's a different study. It's very simple setup. If you have your model somewhere, you can specify a point in space that represents your viewpoint. It's where you're viewing from. Imagine a camera, surveillance camera. You have this point here, for example, and then we can place this point in here. We can put here a point and we can set one point. This is now set here. And we can still move this point around, as you understand. We also need the view geometry. This is the geometry we want to look at. I will select everything. Select surfaces. I get a B-wrap container. Add all my surfaces. I can hide all these, by the way. I don't need it anymore. And because these are my generated buildings, I can also put these in here. So I can take this and place it all here and here. Shift with shift, and now I should have 53 values in here. There's 53 geometries, and then you can put a context. If you have a bigger city context, you can place that in here if you want. Then we have a resolution. You can go through this text and read about what this does. I would just stay with the default value. I think that's fine. Yeah, that's a bit strange now because if I don't have any geometry in the space, it will hide the stuff. Let's not do that. Let's have this actually. I'm gonna put here something. Yeah, you can see this is a bit dumb. Anyway, it's just I could also use a different shader. Nevertheless, so I just placed this here, so it makes more sense. By the way, the path is gone. Why is the path not here? Interestingly, I'm gonna add this. You can add things, by the way. You don't have to always re-select everything. You could go into here and see manage prep B-Rep collection, and seems like this is missing, so we can add an item. We just select this one and add this item. Okay, now this should be added. Perfect. A few other things missing actually, just realizing this one and this one. Let's also add this here. All right, so now we have everything. We can hide this. All right, actually I want to hide everything. Yes. This is really drives me crazy. I actually thought I had everything. Finally. Okay, now we have everything selected. We can also now hide this if you want. Actually, this is the output from here. This is the mesh here. This is the colored mesh. We can hide this and also this one. Don't want to see this. The point. Yeah, let's leave it. So this is my geometry. It doesn't look very nice. It's the typical Grasshopper geometry preview. We can also just look at this in wireframe. Maybe that's more interesting. Anyway, now what does this actually do? So let's examine. We have a study point, we have a view geometry, and we have a context. If we have a city, we have the resolution. You can also specify the CPU count, how many CPUs are used for the calculation. I'll just leave it as default, and then we have a run button, and this already ran very fast. It's super fast because it's quite a simple study. And now you can't see anything. We can look into here, view vectors. So this is the vectors from the point to the objects. We could visualize these probably. Where's the vectors? Forgot. This is in visualize display. Sorry, vector display. The anchor is here, and then we have the vectors. Now you can see the vectors. It's basically the vectors in all the directions from the point. And we have, how many do we have? 300. Yeah, this is based on the resolution here. It's a whole sphere of vectors. Imagine you have an eye which can look in 360 degrees or in all directions. We have a patch mesh, and this is the most important. We need that, and the int matrix. The int matrix. What does the int matrix is? Okay, patch mesh. Let's see the patch mesh. A mesh that represents the sphere of view patches around the study point at the input resolution. There is one face per patch, and this can be used along with the int matrix to create a colored visualization of patches corresponding to different geometries around the point. Specifically, the Ladybug spatial heat map component is recommended for such visualization. Note that only one sphere is ever output from here, and in the event that several study points are connected, this sphere will be located at the first point. Therefore, to create visualizations for the other points, this mesh should be moved using the difference between the first study point and the following study point. We just use one point for now, and you will immediately understand when you see it. But it took me a bit. But we can get the spatial heat map, and we can get this here, patch mesh. The mesh. This is the mesh coming out, and you can actually see here mesh. It has 606 vertices and 300 faces. 300 faces, 300 view vectors. So we have view vectors and meshes. Now, and then I was looking at factors, view factors. Then I thought, this must be the factors which give you a list of no view or full view. Means 0 is no view and 1 is full view. And I thought, I'm gonna put this in here. Of course, that doesn't work because there are only 78 view factors in here. Don't know why, don't know exactly yet why this is done like that. But what we actually need to get is the int matrix. Int matrix, I assume it's an integer. I'm not sure why they make it so hard to understand. A matrix object that can be connected to the Ladybug deconstruct matrix component to obtain detailed vector by vector results of the study. Each sublist, also called branch of data tree, represents one of the points used for analysis. Each value in this sublist corresponds to a vector used in the study, and the value denotes the index of the geometry that each view vector hit. This can be used to identify which view patches are intersected by each geometry. If no geometry is intersected by a given vector, the value will be -1. Now we just follow what it says here. Deconstruct matrix. Let's put this in here, and now we have values. And now we can place the values in here, but let's have a look first what these values look like. -1, -1, -1, -1, and then 75. It seems like how much percentage you see of the objects in total. That's what I understood. Let's put this in here. Now what we get here is, interestingly, we get a very strange, because we need to go back here. Okay, now it makes a bit more sense. So now this sphere is created, and we had to go back to our preview. But now if I look at this, you can see it's all blue on the top, but on the lower side, actually it has colors from red to yellow to light blue, light green, and so on. This is the percentage of what can be seen from each of the objects. How much can be seen of each of the objects. If I go further down, it's automatically updating the calculation, by the way. So if I go into the level of a person walking by, you can see quite a lot of the ground, of course, but overall the view percentage is less than further up because you don't see everything. You see a lot of from that side, but you don't see the other side. You don't see what's going on behind here, and so on. That's how I understand this view factors. And of course you can experiment with more points. -1 means there's nothing. You can't see anything of this geometry. Okay, now let's jump into the next thing. We covered the view percentage. What about the view rows? Okay, let's check it out. The view rows, we can again here place a center point. The center point of my view. Let's do it like this. Okay, this is my view here. The context is my... Oh, we have things twice here. That's not good. Let's get rid of this one. That's not good. Okay, disconnect. It shouldn't change too much really. But yeah, let's make the calculation easier. Context would be now my model, which is this one here. Yeah, this is something we didn't had for a while. This is cool that this came back because everybody was looking for this. The legacy tools actually had the view rows, and then it was gone for a while, and now it's back. And it seems like it's much faster to calculate. Really nice. So okay, the center point, we have the radius. You can specify the radius because we don't need such a wide radius here. 100. Oh, let's put 100 meters, and we can go lower. Of course, this is just what you see inside. Yeah, fantastic. Just keep in mind that it doesn't give you a realistic, it works very well in a city environment where you have tall buildings which block your view completely. In my case, where I have a terrain going upwards, it's a bit different. That's actually a distance value. So you can actually, very useful by the way, you can see the distance, how far the things are away, at which distance your view is blocked. But in that case, if I would stand here, I would still see the buildings. So you need to imagine it as a flat plane. Now there are view types in here as well, which is probably addresses that problem. So let's see. Again, you have a resolution with legend parameters. We talked about this, but the view type are important here. We get another slider, and we have how many options here? 4 options. 0, 1, 2, and 3. 4 options. So let's put this in here. 3 is the maximum. 0 is the minimum. 0 would be the default, I think. Yes. Horizontal radial view. If I put this in here, 1. This is the horizontal 30-degree offset. You get a very different cone now. This is quite interesting. Let's see if I go further up. That's a bit tricky because we actually cannot see the values properly. So if I go below here, then we see a bit more. For sure there's a way to cut through this. Let's check out the other one. Spherical, or the spherical view, the percentage of the sphere surrounding each of the test points. Let's check this out. It's supposed to be yes, okay. It's great. I'm just not convinced yet with how this. It's also hard to select now. I can imagine if you have now a lot of tall buildings. Let's try this. Okay, let's put something here. Something here. And let's add this to our calculation. It makes more sense in a bigger context. Let's see if we would export this. Let's put a mesh here. Yeah, you have a mesh to look at. It's pretty cool. Then you could cut through probably. If I now use a clipping plane, would that change anything? I gotta use this for my intro. This is it's not bad. View rows, pretty cool. I really like this stuff, and I'm really glad it's back. And let's try the last one. Oh, this is like a hemisphere. Okay, hemisphere view from your point. Let's get rid of these. Interestingly, I still need to figure out how we can view this the best way. Let's try this clipping plane again. Clipping plane. Yeah, that's maybe a way to do it. Gives a bit of an idea how that could work. Oops. View analysis. Sorry. No, view rows. View rows. Fantastic tool. It's much faster. So that was the problem. I think the problem was in the past that it was very slow, and they probably changed. They probably had to figure out how to make it much faster. It seems like now it's super fast. I want to, and it seems like it has less bugs or like these weird artifacts. You still have it some way. There's a hole in the geometry. But I remember the first tool in the legacy package didn't work always, and it was very slow. And it seems like this has been improved a lot. I could play here quite long. It's just very satisfying. Alright, so what is the last one? The last tool we'll need to look at. Let's hide this. The last tool here is the visibility percentage. So this is the opposite. So imagine before we said you have a hotel and you have rooms in a hotel in a city, and which side of the hotel has the best would have the best views into the city, and that you can do with the view percentage. Now the visibility percentage is the opposite. How much do I see the object? Let's get this. So you can specify viewpoints similar to the view factors. So you remember we specified a view factor, and then it created this sphere around which shows us the percentage of how much it sees of the objects. And this one now works slightly different. We can specify more viewpoints also. We could have done that before as well, but here specifically with more viewpoints. Imagine you have a site and you need to have, the government tells you, for example in China, if you have a privately owned public space, and then you have to have surveillance cameras, the police will tell you have to have them, and they will also tell you where they are. And with this study you can actually optimize where they should be and what they see, what these cameras see. So viewpoints, let's check this out. Let's specify more than just one point. Let's say I want to have a surveillance camera here. I want to have one here. Oops. It's just very quick. And I place my points here. Multiple points. Let's start with 2 points and we can add more. Point weight. I will leave that. An optional list of numbers that align with the viewpoints and represent weights of importance. So you say this camera is more important than this camera, or this view is more important than this view. That would be actually a really cool tool with Galapagos, a study with Galapagos again, where you optimize views and you specify which views are the better or the more important ones. For example, you have a square and you need to place an object into that square, a statue or a water feature, a fountain or something like that. And you want to understand where on this square is the best position. Then you could use the study and you can weigh the different viewpoints and say, this is the main street where most of the people will come, and this is another side street. Then of course they have a different weight. So that's where the point weights make a lot of sense. In our case, we want to put surveillance cameras and want to understand, we want to cover everything basically. The geometry would be, again, the entire geometry. Can place this in here. And context, again, this is the optional context around. At the moment we don't have anything here. The grid size, this is now because we creating a mesh of all this stuff, so it will determine a grid size of that mesh. We can go in here and say, let's start with a bigger number. I start with 2 meters, a 2 meters grid size, just to see that the calculation is quick. And then we have the offset. This is the offset from the surface. We just leave that. The maximum distance. What is the maximum distance I want to actually check? So for example, I know that from a certain distance you cannot recognize faces anymore. That's my maximum distance where I want to look at. You could specify that here. Geoblock, I'm not sure. I think I heard it before in the other tool. Set to true to count the input geometry as opaque. Oh yeah, it's either opaque or transparent. Your input geometry. It should be opaque. Default is true. Okay. Then legend parameters again, a CPU count and a run button. We need that as well. Okay, put this to true. Yeah, and yeah, good. That was quick and dirty. Now let's see if we can make this a bit finer. Okay, now you can see here. All right, we don't see anything. This is 100%. We can see 50% of this area, the green. I'm wondering why it's 50%. Is maybe because of the angle. And now we could add more points. So first we could, again, it would be perfect now with Galapagos. I think in the next video we look at the Galapagos version of this. How many points do we need, and how do we need to organize them in order to see everything? Okay, I will just take this point and make a copy. Oops, that was not what I want. Let's just get another point here, another point here. I'm just adding some stuff. This is just very random. It's not very organized. Just show you that what I mean by now you could add more cameras and see if that changes the output. But it's not about how many cameras, it's about, of course, where you place them. Manage point collection. Can I add this? No, that's very strange. Let's do this. Okay, let's select these. 1, 2, 3 and 4. Yeah, I can see a bit more, but it's actually not very good. So we probably need one at the lower end on a certain level to really have an impact here. And then it becomes a bit far, so you don't see that much because of the angle. But yeah, that would be a very interesting study for optimization with Galapagos. I think you get the point. So what it says, how much of my geometry is visible to these points? And cameras, yeah, they're not 360, probably not. And you need more cameras if that is the case. But of course, it gives you an idea of where you would need to place the cameras in order to have the best impact. And there are some blind spots here, but yeah, I think it's pretty good. All right, I think that's it. Let's check it out again. Visibility. So we covered Ladybug view factors. We covered the view percentage, view rows, and the visibility percentage. I think I will do a video about Galapagos with these tools, with these new tools. And then we look at some of these other, I think we already covered some of these because we had to use them before, but we will look at it again. The Ladybug Sky Matrix, the Solar Envelope, and Surface Ray Tracing. Interesting stuff. I think that was not there in Ladybug 1.6. Ladybug Shade Benefit, Thermal Shade Benefit, a real-time incident radiation. Alright, that's it for today. I hope you enjoyed this. Thanks again for my new members. Highly appreciate it. just text me and ask whatever you need to ask. All right, see you in the next video.